This is Algebra 1, Term 5, Lesson 11, Quadratics Rewind. We'll begin with the Desmos activity, and then we'll come back to slides to work on the discriminant, and finish up with a poster project. So let's get started. The Desmos activity is longer, 3 forms for quadratics, but it should be reviewed, so hopefully the kids will go quickly. There are a total of 23 screens. On the first screen, they're simply going to move this until they can get the gates to fill in. So they'll drag the movable points so that the parabola passes between the gates. When you are successful, the gates will be filled. So there are multiple ways to do that because they can move this around different ways. They'll repeat the process here, except now they have 3 separate gates to go through, so they need to make sure the parabola goes through all 3 of the gates. Now that's just to get them started, because on this activity they're simply going to type an equation to create a parabola that will go between these. There are an infinite number of possibilities, so encourage them to be creative. On this one, they're going to choose the equation that might represent this one and explain. Maybe this would be a great time to have a conversation. Why couldn't this have worked? Why couldn't this have worked? Maybe once the students have chosen the answer, why the other 2 are not possible based on this graph. Here they're going to create an equation for a parabola that passes between the sets of gates, and then press try it. There's no direction on how to create this equation. It should say y equals, but the form is kind of up to them. This equation is written in vertex form. What is the vertex of this graph? And then explain why it is called vertex form when they explain their answer. Most of these are self-checking, but some aren't. So my suggestion would be to put your dashboard up and anonymize the dashboard so that kids can see how they're doing as they go. This equation is in factored form. What are the x-intercepts for this graph? Submit and explain how to find the x-intercepts using only the equation. This equation is in standard form. What is the y-intercept of the function? Submit, explain how to find the y-intercept using only the equation. There are sample responses and teacher moves on many of these slides, so be sure to check those as you go. In this problem, the equation was given to them in factored form, and they're being asked to convert that into standard form. It does say explain your thinking by inserting a picture of your work. Now, the way I handled this is I had kids create a box and put the factors on the sides and multiply and fill in the box. And then they would choose the answer. So in this one, same thing, but this time the equation was in vertex form. They would square the binomial with the box and then combine the constant with the -1 that's in the equation and then choose their answer. So let's say this is the answer. When they do that, you notice this has an upload image. That's where they would put the image of their box, or if they wrote it out on a whiteboard, that's usually how mine did it. I would take a picture or have the kids take a picture and insert that here. Okay, which of these equations fits this graph? Kids could talk about the transformation of the parent function here. These are opportunities to talk. So I would pace your kids, call on groups, call on individuals. Let's get kids having conversations about why these things are doing what they're doing. They should be really good at the transformations at this point because we've been doing them for quite a while. So write an equation in vertex form for this graph. Write an equation in the form y equals x squared plus k. So this is technically standard form and vertex form, so you could talk about that. Why is that so? How could one equation be in both forms? Which equation reveals the x-intercepts of the graph? Which equation reveals the y-intercept of its graph? What is this form called? And then once you've submitted, so notice that these questions are being asked again and again, but from a different direction. What is this form called? Submit and then explain what this form reveals about the graph. What is this form called? Submit and then explain what this form reveals about the graph. This quadratic parent function was translated left 2, up 4. So if the quadratic parent function was translated so that it looks like this one, then write an equation in vertex form. The quadratic parent function was translated right 3 and down 1 to create this graph. Write an equation in vertex form. On screen 22, the quadratic parent function is reflected over the x-axis and then translated 6 units right to produce a new function. Which equation could be the new function? And then finally, they're going to sort these cards into 3 groups of 4. So there's just 3 functions here, but each of the functions has equations in 3 different forms. When we're finished with the Desmos activity, we'll return to our slides. Now the first task in slides is to go to GeoGebra and explore the quadratic equation and the discriminant. So this is their first introduction to discriminant. I don't spend a lot of time on this. I even skip it some years because my professional opinion is that probably should be left to the Algebra 2 class, since the students are going to get into imaginary solutions and simplifying solutions that are imaginary in that course. So it's up to you whether you even want to do this, but I did go ahead and do it. When they go to GeoGebra, it's doing nearly all the work. So it's really pretty simple. So when they get in here, they're going to see something like this, and they can adjust the values for A, B, and C. And then as they do, they're going to see some things on the screen. This is a good time to talk to them about some of these words. We've not really used the word roots as much as zeros. We've talked about the zeros of the functions, not so much the roots. But you could talk about that really is one and the same, especially when they're, the solutions are the roots in these where the value of the discriminant is positive. But sometimes the discriminant is nice. Like this one is not so nice. Sometimes it's nice. We can make it a positive number, a negative number, and sometimes it's not nice. So sometimes our discriminant's a fraction. Sometimes it's not a perfect square. So they should examine all that and look at the graph and look over here. And they should also notice that the b squared minus 4ac, the discriminant, is really just part of the quadratic formula. So back in the old days, before the calculator, we used that to make a lot of judgments about what the graph was going to do or what the solutions were going to be, because it was much more tedious in the old days to graph quadratic functions. Now with the technology, this is probably obsolete, but unfortunately these things are still coming up on our SATs and our ACTs and some of these other state tests, so we have to at least expose kids to these concepts. But like I said, I do skip this in Algebra 1 in some years, so it's not critical that they do this. Let's go back to slides and see what we need to do. On the first one, they're going to move the sliders to create a discriminant that is a perfect square. You might need to review that definition if they've forgotten, but perfect squares are where the sides of the square are integers and the area of the square is the perfect square. So what do you notice about the x-intercepts in the graph? They should type here and insert a screenshot of what they created. On task 2, they're going to create a discriminant that is negative. What do you notice about the x-intercepts in the graph? They will insert their screenshot. For task 3, they will insert a discriminant that is a positive number, but not a perfect square. What do you notice about the x-intercepts in the graph? And then finally, make the discriminant 0. What do you notice about the x-intercept of the graph? Now there is more to this. I put in their show notes some questions. So let's take a look. On each one of these slides, they're being asked to classify the solutions in as many ways as possible. But real, imaginary, irrational, rational, integer, whole, natural. They could also delete all the ones that it's not. So if they want to do it that way, that works too. But the point here is to notice that certain discriminants will give you certain solutions. Hopefully as they're working in teams, they'll take note of what's happening with their classmates as well, so they can get more than one example of each of these. Alright, the next part of the slides include solving by using algebraic methods. Now I've given them 4 different slides and they need to choose a method. Those methods will be in their show notes. So down here they can solve either using factoring, quadratic formula, completing the square, or inverse operations. So on the very first one, you can kind of tell which one they're going to do here, at least I hope so. And then once they've chosen that, take it off the list, because they want to try to use each method only once as they go through. Once they've solved their equation, they've inserted a screenshot of their work. Mine would do this on a whiteboard. They will check their answers by graphing. So the way they do that is they just type the equation as is into Desmos, and it will produce two vertical lines where the solutions are, and then they type their solutions on separate lines in their calculator, x equals, and it will also produce vertical lines. If they haven't messed up, then those vertical lines should fall right on top of the vertical lines they got with the equation. So that's how they check by graphing. Now there's one of these where they get a negative under the square root, and they can graph it, but nothing's going to appear in the graph. So my suggestion on that one, to show the graph, don't put the equals 0, because one of these has equals 0 in it like that. Just don't put that, and they'll be able to see that the parabola does not equal 0. It doesn't cross 0. So they can use that graph to show why the solutions are imaginary. And here's another one. And here's another one. Now you may say, well, what if they complete the square when they should be factoring? Well, if you want, you can just say do it however you want and ignore those instructions or even delete those instructions. But my goal is to get them to practice the different methods and realize that there's different ways to solve quadratic equations. We kind of want to review all the methods. Once they've solved using all their methods, they're going to go to their poster project. Now, here are 3 equations. They will choose one of those equations. Now, from my experience, they end up playing with all 3 for a while before they make a choice, and I'm actually kind of hoping they do that because that gives them some more experience, more exploration, and that's good. So as a team, they will choose one of these functions to create a poster as a team. I have done these in pairs, and I've even done these individually, and I have work samples I will show you in your teacher slides of this exact project. But they are going to create an equation in vertex form for their function. Of course, they can graph their function in Desmos to find the vertex and do that. They can create their equation in factored form, but notice it does ask them to create a box to show how the vertex form is related to the standard form that's given. So they should be able to put their factors on a box, and they should put this trinomial inside the box and show how the two are connected or related. You may notice that the first function, and it's the only function, has a common factor of 2. Do you have to factor that out first? You kind of need to. If you don't factor it out first, it kind of makes a mess of your factors. But, you know, I usually would take the factored form in any reasonable form as long as the factors did have a product equal to this trinomial. So that's kind of up to you. To see that value of a that's in vertex form, they kind of need to factor out that 2 first. And then they're going to solve that equation 4 ways. They're going to factor it, they're going to graph it, they're going to use the quadratic formula and complete the square. And when they do the completing the square, they're technically using inverse operations, so they're really doing 5 methods if you think about it. They're going to put all the work onto a poster to display, and they will put a photo of the team poster on this slide. Now, as the posters are displayed in the classroom, in the hallway, or wherever you decide to put them, I have the kids take a pack of Post-it notes and go around, or sticky notes, go around and put a sticky note on a poster and then write something on the sticky note, and that could include questions they have about the work, things they learned from looking at someone's work, things they found interesting in their work. So they should choose one of those things or more than one of those things to put on sticky notes and place on the posters. This way they are reviewing hopefully more than just the one function that they decided to do in their poster. The purpose of these last few lessons is to get ready for the big benchmark exam, which is going to see where they stand for their state test. So it's important that they review lots of different concepts, and that's what this lesson is all about. And that concludes Quadratics Rewind. We have 3 more lessons until the benchmark exam. Y'all have a great day.